Hello, welcome back to another episode of Mr. Rocks. And in this episode, this is lesson 5 of Phat Kids. We're going to be adding to our program a couple of things. We're going to be working in the Phat Kids class. And in the Phat Kids class, we're going to end up loading an array of waypoints. Now, waypoints are going to be these locations in the play area that each enemy is going to go from waypoint to waypoint to waypoint. And as we move the waypoints around, the enemies will follow whatever path we tell the enemies to follow. Then we're going to go over to the enemy class itself, and we have to add some code and actually a couple of methods that are going to allow us to tell the enemy how to find these waypoints. But first we need to load an array of waypoints, and so I'm going to need some variables up on top. I will take, here, let me put this in. I'll just say lesson 5. To make sure we know that this is all coming for lesson 5. A couple of variables. One of the variables I'm going to have is a guy called waypoints, and this is going to be an array of waypoints. But right now I will say array simply here, and then down here I've got this guy already loaded in. It says waypoints equals new array. This is important that we understand that the reason I don't just put this all on one line here is that if I just simply left this out and put the var here, what I would do here is I would declare the waypoints down here, and then I instantiate it, and it would then only be seen between these two curly braces. But if I do it this other way, where I have up here outside of, this is underneath the class declaration, and it is above the constructor function, and at this point, because it's declared out here, it can be seen by anything in this class. And I'm going to be calling this, I'll be using it in a couple of different places, so I need its scope to be throughout the entire class. So that's why that's up there, and then I instantiate it right here. I declare a new array, and then down here I'm going to create at the very bottom a new function. So I will say public function, and I'm going to call this function load waypoints. And I'm not going to receive a parameter, I'm not going to return anything. I'm going to load this with waypoints. And we're going to do this in kind of an interesting way. If I come back to my Phat Kids class, and I come back to play area, which is something that I created, I've created a new movie clip, and this movie clip is called waypoint. And this waypoint is nothing special about it. It's simply a little star. It could be anything really. It's just I need to see where it is on the play area, and then on the play area I went and I dragged these guys out. So on the play area I simply came over and dragged a bunch of these stars out. I simply came over and dragged them out one at a time. The important thing is, though, is that when I dragged them out, I was able to select each one and name them. And in the scripting language, ActionScript, I can reference each of these if I follow a deliberate pattern in the naming convention. And what I did is I had capital letters WP followed by a number. So that's the first one. Notice the second one is WP2, WP3, WP4, and so forth. And it's important that I follow some convention because I have to tell the scripting language how to find each of these waypoints. And so if we come back now to the Phat Kids class, the way that I'm going to do this is I am going to first of all set up a variable. I'll call it I, and then we'll just make this an int. I will set this equal to 0, and then I'm going to create a new kind of object that we haven't created before. I'll call this guy waypoint object. And the important thing about the waypoint object is that it is going to be something called a display object. And so I need to set that up on top. And let me go ahead and come back up here. Waypoint object is going to be right here under my waypoints array. And I'm going to have this, we'll call this a variable. Now, I'm not going to instantiate this, but I'm simply going to declare it as a type, and it is going to be a display object. Now, what's interesting is the display object you cannot create an object of this type. You can't instantiate it. You can't create an instance of this. It's simply kind of a superclass that other classes are built from this class. So for instance, movie clips and sprites all are types of display objects. But what I can do is, since this waypoint object, I can put, now since this variable is of this superclass type, I can put any of the subclasses in this container. So think about this as like a big box. And I can put a movie clip in there, I can put a sprite in there. In this case, I want to put a movie clip in there. And the movie clip that I'm going to put in there is actually the waypoint, because I need the x and y coordinates of each of those waypoints. The way that I find the waypoint is I'm going to, since these waypoints exist on the play area, and I've already instantiated that. Remember here I said PA equals new play area. So because I put the declaration for that way up here on top, it's outside of any of the methods, I can see PA now from anywhere in the program, and I can use PA. And there is a method that I can use specifically for this purpose, and it's called get child by name. And we can see if I hit Control spacebar, get child by name is right there. And now what I need to do is put the naming convention was a string WP plus the integer, which I'm going to call I. Okay? So now I is going to vary from 0 to 1 to 2 all the way through my last one. And so first of all, I is 0, so I don't have an int 0. I do have a 1, so I'll call that I is equal to 1, and so WP1 was one of the waypoints that I have on the play area. Now what I need to do is I'll come through and I'll use a new kind of loop. This loop actually looks more like an if statement than a for loop, and it's very simple to use. The difference between this and an if statement is that we're going to continue to do this as long as my condition is true. An if statement checks the condition. If it's true, it does the code one time and then you move on. A while loop, if the condition is true, it continues to do this until the condition is no longer true. And so since I don't know how many waypoints I'm going to have at any given time, I'm going to have this code is going to be flexible, and I'm going to have in here a condition. And the condition is that waypoint object, and I just loaded, or I should have loaded, the movie clip into this. So if this guy does not equal null. Null is another way of saying empty, or it doesn't exist. So if this says it doesn't exist, if it's not empty, you can think of this as empty. If it's not empty, then it exists, then I'm going to come in here. As soon as this container is empty, then I no longer want to do this. And so what I'm going to do when I come in here is I'm going to push this object into my array of waypoints. And there's a way of doing this. So waypoints is the array that I created up on top. So I created that guy right here. I declared waypoints as an array, and I said it's a new array. And actually, I don't have to tell ActionScript how long this array is going to be. And I can make it as long or as short as I want. But to add a new element, I use the special keyword push, and I have to tell it what I'm pushing. And so what I'm going to push is waypoint object, and I'm going to push that into my array. Every time I come into this loop, or every time this guy is not empty, that means there's something in it. I'm going to push it into this array of waypoints. And I'm going to keep doing this. All I need to do now is say I++. So I'm incrementing I. And then I'm going to take this, I'm going to grab, or I'm going to try to grab another instance of this on the stage. So in this case, I was 0. If it was, I'm sorry, I was 1. If this exists, then it's going to come in here, and I'm going to push this guy into my first element of my array. I is going to get incremented. Now I is equal to 2, and so I'm going to look for this guy called WP2. If he's on the play area, I'll get that guy by name. I'll look on the play area, get child by name. If I've got a guy on the some object called WP2, then I'll come back up here. I'll load that in waypoint object, and then I come back in the loop. So I keep coming around this loop over and over and over until at some point I'm going to come in here. There's not going to be, let's say, a waypoint 45. In that case, there's this guy's null, and I break out of the loop. And that's really all that's going on. So while loops work very much like for loops, except they look more like if statements. I have to have a precondition, I have to check that condition, and then I have to update that condition. The same three things I do in a for loop, but I'm doing it here a little bit differently because I don't know how many stars I'm going to have. If I knew I was going to have exactly 10 stars, then a for loop would work just fine. The other thing I'm going to do to change this is I'm going to come over here, and inside of the enemy function, init_enemy, I'm going to add waypoints right here. And so we haven't done this before, but we had before just enemy class. We said new enemy, but now I can send enemy my whole array of waypoints. Now this is not going to work right now because if I'm sending an array of waypoints, I've got to tell enemy to receive that array. So I'm going to go ahead and leave this part here. Now we're going to go over to the enemy array, and we're going to make the necessary changes there. Okay, now that we've got our waypoints in order, we need to go ahead and make some more changes in the enemy. And this is going to be quite a bit of change, actually. So hang on, and let's see if we can get all of this done in about 5 to 10 minutes. In any case, I'm going to come back into my init enemy, and when I create my enemy, now I want to send in my array of waypoints, which I have loaded. Notice that when I call this, I've got set area, I never called this function, so I'm going to call this, I will call load waypoints, which is the method that I created down below. So load waypoints, it doesn't take any parameters, so I can just leave that empty. But it's important that I set area first because waypoints is going to need this. And so if I just simply reverse the order of these two calls, put load waypoints above this, then PA doesn't exist and load waypoints can't use it. So this order is important. Now I'm going to come in here, since this guy is sending enemy waypoints, I need to accept waypoints right here. So I'm going to create WP and call this an array, and since this is going to be an array of waypoints, you'd think I can just use that, but it's not quite that simple. I need to set up another variable here, and this is going to be variable, I'll call this waypoints. This waypoints array is going to be, again, of type array. And the thing about this is, and again, is since I'm declaring this between the class and the constructor function, anybody inside of this class will be able to see this. Whereas this guy is getting sent into this constructor method, the only place in the program that I can see WP right now is inside this method. So I'm going to say waypoints is equal to WP, and now waypoints is going to be, I have access to that array of waypoints anywhere in this program. I'm going to change things around here a little bit. I'm going to hit this button to comment all of that code out, and what I'll do now is I have to create, I've got to get the distance to the next waypoint. So right now, if I were to run the program, it does run, and notice they're not moving anywhere. They don't know where to go. If I uncommented this, I guess they would do exactly what they were doing before. So let's save that, run it. So they were doing exactly what they're doing, but now what I want them to do is to follow the waypoints. So I'm going to comment this code out, and I'm going to, first of all, I want to get the distance to the current waypoint. Now, the current waypoint is going to be whatever waypoint is in the array. Remember, this code is inside of each of the enemies. So each enemy has its own current waypoint. And what I need to do is create some more variables up here. So I'll create a variable called current waypoint, and I'll abbreviate that a little bit, and that'll be of type, let's say, number. Come on. Number. And we'll set that equal to 0. And I'm going to have another variable called, let's see, let's do current waypoint, let's do distant to waypoint. So I'll say dist WP, and that again is going to be a number. And not num children. Let me try that again. Number, and that's going to be equal to 0 as well. Make sure I use my keyword var. And so now I have a couple more variables that I can use. At this point, I'm going to call a method, and I'm going to say distance WP. So dist WP is equal to, and I'll say get distance to waypoint. That seems like that will work. And then I want to say if distance to waypoint. So I'll take this guy and I'll say if that distance gets small, let's say less than, I don't know, let's say 5. If it's less than 5, then what I want to do is increment my current waypoint. Now remember, each enemy is going to have this version of its own code in here. So cur waypoint is going to be specific to each individual enemy. But I'll just increment that. So the point is I've got an array of waypoints. When cur waypoint is equal to 0, the first element of the array is going to be waypoints. Cur waypoint or waypoint 0 is going to be the first waypoint. And then I'll increment that. I'll point to the next waypoint and the next waypoint and so on and so forth. And so when I run out of waypoints, that means I'm done. So at this point, I don't have this method, so let me write that method. And I'll say again, public function get distance to waypoint, and I need to have no parameters coming in, nothing sent. Oh, I do need something sent back. I need to send a, let's see, distance to waypoint is a number, so I will send back a number. And now I just need to calculate that. So the distance to the waypoint is going to be calculated by using a little bit of good old Pythagorean theorem. First of all, I'm going to create a variable called dist, and that's going to be the type that I'm sending back, and I'm going to set this guy equal to 0, and I'll take that back. I'm going to set him equal to a negative number, because the way we're going to set up the distance, if I do calculate a distance, it will have to be positive or 0. In any case, I set that guy, and now I need a couple more variables. I'm going to need dx and dy. Both of these can also be numbers. And I'm going to calculate, the way we did before, the distance between the waypoint and this. This is the enemy in this case. So to calculate that, I'm going to say that this is equal to, and I will go into my array of waypoints, and I'm going to look at the current waypoint, and I'm going to, this is going to tell me what's inside. Well, I've got an array of movie clips, and so each movie clip has an X and a Y property, and now I will simply subtract the X value from this, and that will give me the X distance between my enemy, the current enemy, whatever this happens to be. I could also say this dot X, by the way. And I'm going to do the same thing for Y. So now Y is going to be equal to waypoints, current waypoint. I'm going to have a Y here and a Y here. And with dx and dy, now all I have to do is calculate the distance. The distance is going to be the square root. So I do math square root. And I'm going to put inside this, you know, a squared plus b squared equals c squared. And so c is equal to the square root of a squared plus b squared. In this case, dx squared, I can say by just simply going dx times dx plus dy times dy. And now the problem with this is going to give me, no, I take it back. I think that's all I have to do there. I don't have to worry about radians or anything like that. This is not an angle thing. So at this point, I simply need to return distance. However, there's one other little piece that I need to add in here, and this is a action script detail. I don't want to do this if the if this thing is null, if waypoint's current waypoint does not exist, I need to check that. So I'm going to say if that does not exist, if it does exist, then I want to come in here and I want to do this part. In other words, if I start referencing an element that doesn't exist, let's say current waypoint is 50, but my array only has 40 elements, I'm looking for something that doesn't exist, and the program will throw an exception. So the way that I deal with this is I only have to go in here if waypoints, current waypoint, does not equal null. And so at this point, let's see if we can format this so it's a little bit neater. It says I've got an issue. See, this all looks good. Return dist. Number. And it does, oh, I don't have a, really? Oh, I don't have an equal sign. So dist equals, and I don't think ActionScript minds if I don't have, okay, so now nothing's moving, but at least this is working. It's calculating the distance, so no more errors there. Now the other thing I need to do after I've calculated this is I need to move the enemy. And to move the enemy, that's going to be a method that I have to write, and I'm going to try to do this really quickly because I'm really out of time. But to move the enemy, I need to simply orient its rotation towards the next waypoint. So this is going to be a function called move enemy, and let's see, it does not enemy, good. It's not going to return anything, and it will be public. And I have to do a couple of things here. First thing I have to do is I have to orient this towards the enemy. So I'm going to calculate dx and dy again, so I'll just copy that code down here, and then I'm going to go ahead and say the rotation, I have to point my enemy towards the next waypoint. And so to do that, I'm going to use my math class again, just like I did before. I'm going to say atan2, I'm going to put in dy and dx, and after that, again, I have to do the whole conversion. So in this case, I need to convert from radians to degrees, so I'll say divided by math.pi, and then times 180. At that point, this guy is converted, so the rotation should be oriented towards my enemy, and then I just need to take this code, which I had before, and move it according to sine and cosine, and that, I think, should do it. Now I can erase this completely, save everything, please run, because I want to be done with this, and they are running. Okay, so they're not following the waypoints exactly. I'm out of time, so I'm going to talk about that during the next one, and so that's it for today. Bye-bye.